October 1957. A polished metal sphere crosses the night sky and broadcasts a simple radio pulse. Sputnik 1 is small, but its political effect is enormous. The Soviet Union has placed the first artificial satellite into orbit, and every other country is suddenly behind. On this chart, the Soviet series begins with only 2 registered objects. That tiny red bar marks the opening of the space age. Over the next 3 decades, it will become the most productive space launch system on Earth. Then, the lead will disappear. By 2025, the same historical series records 89 objects in a single year, while the United States records 3,708. Russia still launches spacecraft. The astonishing part is how completely the scale of the race changes around it. First, read the chart carefully. Each bar shows the number of objects commissioned by a country and registered as launched during the previous 5 years. The source is the United Nations Space Object Register, processed by Our World in Data. A 5-year window smooths one unusual year and makes long changes easier to see. The month between 2 annual observations is visual interpolation. The underlying records are yearly. These are objects, not rocket launches. One rocket can release dozens of satellites. The metric also does not measure payload mass, mission quality, military capability, scientific importance, budget, or profit. Soviet-era observations are harmonized in the source under Russia. We display that same series as the Soviet Union through 1991, then Russia from 1992. With those limits understood, the movement reveals a real transformation in who can manufacture and deploy spacecraft at scale. The American answer begins almost immediately. Explorer 1 becomes the first United States satellite in January 1958. The response is larger than one mission. New launch vehicles, tracking networks, research laboratories, military programs, and NASA itself turn the shock of Sputnik into a national industrial project. By 1961, the American 5-year total reaches 66 objects, compared with 16 for the Soviet series. By 1965, the United States has accumulated 305 objects in the trailing window. The Soviet total is 143. This early American lead can be easy to forget because the cultural memory of the space race focuses on dramatic firsts. The first satellite, first human in orbit, first spacewalk, and eventually, the moon. The chart measures a different kind of strength. It rewards repetition. Every communication satellite, scientific probe, technology test, and other registered spacecraft adds another unit. During the early 1960s, the United States is building that repetition faster, but the Soviet system is accelerating, and its advantage will come from a launch rhythm designed to continue year after year. Around 1970, the ranking changes. The Soviet 5-year total reaches 342. Narrowly passing the American total of 338. China also appears for the first time with 1 object, a small sign of a future rival. The Soviet lead is not created by one spectacular mission. It comes from volume across many programs: reconnaissance, communications, navigation, weather monitoring, scientific missions, crewed spacecraft, and repeated support for orbital stations. The launch system is highly standardized. Rocket families derived from military technology are produced and flown again and again. Failures in short-lived spacecraft still count when they are registered as objects placed into orbit or beyond, so the chart should not be read as a quality ranking. It shows operational tempo. By 1975, the Soviet trailing total rises above 500, while the United States falls to about 160 after the intense Apollo-era build-out. The red bar now looks dominant because the Soviet Union has turned access to orbit into an industrial routine. That routine becomes the foundation of its long lead. The lead reaches its maximum during the first half of the 1980s. In 1985, the Soviet 5-year total peaks at 593 objects. The United States sits at 127. The gap is more than 4 to 1. Yet this is where a simple winner and loser story becomes dangerous. A large count does not mean the Soviet economy is healthier, its spacecraft are more advanced, or every mission achieves its objective. It means the system is producing and replacing many orbital objects. Some Soviet satellites operate for shorter periods and require frequent renewal. Some American programs place more capability into fewer spacecraft. Different engineering choices create different bar lengths. Even so, consistency matters. A country able to design, manufacture, launch, track, and replace hundreds of spacecraft possesses a deep institutional machine. The Soviet Union has launch sites, factories, design bureaus, trained crews, and an enormous state customer. The chart's smooth red dominance hides tension inside that machine. Economic stagnation, competing bureaucracies, aging infrastructure, and a budget that depends on a political system approaching a historic break. The decline begins before the flag changes. The Soviet 5-year total falls from 593 in 1985 to 534 in 1990. It is still far ahead, but the direction is now downward. In December 1991, the Soviet Union dissolves. Russia inherits much of the launch infrastructure, many design organizations, and the largest part of the space workforce. It does not inherit the same economy, borders, supply chains, or guaranteed funding. Hardware and expertise are divided across newly independent states. Institutions face unpaid salaries, uncertain orders, and the pressure to earn foreign currency. The bar changes from the Soviet flag to the Russian flag in 1992. But the data series remains continuous, so viewers can see the break without pretending that the underlying industrial history started from zero. The trailing total slides from 503 in 1991 to 465 in 1992, then keeps falling. Cooperation with the United States, including the path toward the International Space Station, preserves valuable capabilities and missions. It cannot preserve the old launch volume. A superpower-sized machine is now operating inside a much smaller economic system. In 1997, the decisive crossover arrives. The United States reaches a trailing total of 235 objects. Russia falls to 215. For the first time since 1970, the red bar is no longer number one. The change is gradual on screen because the real decline is gradual. There is no single launch that ends Russian leadership. Orders shrink, satellite production falls, and replacement cycles slow. Russia remains essential in human spaceflight and launch services. Its rockets carry domestic and international payloads, and later its Soyuz system becomes a crucial route for crews traveling to the International Space Station. Those achievements are important. But this chart credits an object to the country that commissions it, not necessarily to the country providing the rocket. A Russian launcher carrying a foreign satellite can strengthen another country's bar. That attribution rule explains why launch provider reputation and object count leadership can diverge. By 2000, the American 5-year total is 356. Russia is at 121. The Soviet-era advantage has been erased, and the next technological shift will widen the gap. From 2001 to 2010, the race looks less dramatic, but its structure is changing. The United States remains first. Russia stabilizes near 100 objects in the trailing window rather than disappearing. China moves steadily upward, from 36 in 2000 to 63 in 2010. Europe, Japan, India, Canada, and other countries appear and vanish from the top 10 as national programs and commercial customers expand. Space is becoming a broader market. Universities can build small experimental spacecraft. Earth observation companies can plan fleets instead of a single flagship satellite. Components become smaller and more standardized. Digital electronics reduce the mass required for useful missions. Launch brokerage and shared rides begin to lower the barrier for organizations that cannot buy an entire rocket. This era does not yet produce the enormous bars visible at the end of the video. It builds the supply chain that makes them possible. Russia continues using a mature system designed around state missions and established rocket families. The fastest growth is emerging in a different model. Smaller spacecraft, private capital, frequent launches, and networks that need many satellites working together. After 2011, small satellites turn a slow race into an accelerating one. CubeSat standards allow teams to design around common dimensions and interfaces. Rideshare missions can deploy many payloads from one launch. Commercial Earth imaging companies replace a few large spacecraft with fleets that revisit the same location more often. The American 5-year total rises from 181 in 2010 to 345 in 2015. China nearly catches Russia, reaching 128. compared with Russia's 138. By 2018, the United States has pulled much farther ahead. This shift changes what a bar chart victory means. During the Cold War, high volume often came from state programs repeatedly placing specialized spacecraft in orbit. In the new market, a single company can commission hundreds of small satellites as parts of one commercial network. Counting objects captures that industrial scale, but it gives every object one unit regardless of size or purpose. The rules have stayed consistent while the object being counted has changed. Russia does not suffer a sudden technical collapse during these years. Its relatively flat output is overtaken by an industry learning how to manufacture satellites more like a production line. Then the chart breaks open. In 2019, the American 5-year total passes 1,000. In 2020, it approaches 2,000. By 2021, it exceeds 3,000. Large constellations, especially Starlink, place dozens of spacecraft on individual missions and require continuing launches to build and replenish the network. The annual United States series jumps from 105 objects in 2015 to 362 in 2019, 984 in 2020, and 1,232 in 2021. The United Kingdom suddenly surges too, largely because OneWeb spacecraft are attributed to their commissioning country. The British government took an equity position in OneWeb in 2020, and hundreds of satellites entered orbit as the network expanded. This is the clearest example of why the flag on a bar does not always identify the rocket or launch site. It identifies responsibility for the registered space object. China also grows, reaching a 5-year total of 536 in 2022. Russia rises modestly to 148, but visually it appears to shrink because the leader has changed the scale of the entire chart. From 2022 to 2025, the difference becomes almost difficult to draw. The American trailing total rises from 4,705 to 11,370. China climbs from 536 to 1,142, establishing a clear second place. The United Kingdom's OneWeb-driven total begins to recede as that deployment phase changes. Russia increases from 148 to 323. That is important. The Russian bar is growing in absolute terms near the end. The title describes the loss of leadership and relative scale, not a claim that Russian activity falls every year. In the 2025 annual observation, Russia records 89 objects, more than in many years after the Soviet collapse. China records 374. The United States records 3,708. The world total is 4,510 unique objects in the source, although country totals can overlap when an object is jointly commissioned. The final gap is driven by a new manufacturing regime in which thousands of similar satellites can be deployed as infrastructure. Russia remains active, but it is no longer setting the pace. So what did Russia actually lose? It lost a quantitative lead that the Soviet Union built through decades of frequent state launches. It lost the industrial tempo that kept the same historical series at number 1 for 27 years. And when commercial constellations transformed spacecraft into mass-produced network components, Russia did not create a deployment system on comparable scale. The chart cannot tell us which country has the best rockets, the most capable military satellites, the greatest scientific discoveries, or the safest missions. It tells us something narrower and still revealing: how many registered objects each national system can commission and place into the space economy over time. In 1957, 2 Soviet objects were enough to shock the world. In 2025, 89 Russian objects represent real activity, yet they are almost invisible beside the thousands attributed to the United States. Russia did not leave the space race. The race changed its unit of power, and Russia lost the lead.